All right, so we'll come back to CAP 6640. Do we have any questions? Anybody complains about me being so harsh in making exams? Oh, this person here, I'm gonna out you. So wrote her comment, what is that? Like in the comment section, this is too long of an exam, right? Yeah, was it long? Eight sentences, then 8 by 8 is 64 sentences. Is that difficult? Do you guys type fast? No? Yeah. You should not complain because you got a really great grade. Yeah. But I mean, to be honest, I'm very happy with like the performance overall. So like that retake has improved grades significantly. And we will do whatever we can so that you guys get the grade that I see, not the grade that you see. So my expectation is that for this kind of course, I mean, generally speaking, I think that a graduate course is 6,000 level, not 5,000 level, 6,000 level course. If you not get an A, you should be disappointed. And so like 25% of the students are going to be disappointed in any class. So this is going to be the rough number. And in the past, I did curve. This semester, I'm not going to do any curve. Either it's going to be like with assignments that are going to be sent out so that we can just have an effort of yours eventually calculated, put into the equation with some weights to get that number in. Or in this case, the retake. And again, technically, the retake was not really planned. It's just that some students were away and wanted to have like a makeup. This is against the policy of the exam. And I did the exam, I made it. And so I thought that we can push it a little bit higher by allowing students to do it. How many of you did not do it? You're happy with your grade, right? Why you not do it? I've seen like some people who are like around that 160 and not do it, or even lower than 160 and do not do it. Why not do it? Huh? Oh, another exam? Yeah. This is a very busy time. Okay, I have some good news for you. How many of you are planning to come here next Thursday, like a couple of days from now? How many of you would not want to come? Do not want to come? Like for this lecture then, who do not want to come? Okay. Who doesn't want to come here next Thursday? Yeah. Huh? No, this upcoming Thursday. This Thursday, 12th, yeah. Okay. All right, so the good thing is that I finished recording that lecture and it's online. And it's going to be the Thursday before Thanksgiving. Sorry, not Thanksgiving, spring break. Some of you might be traveling. Some of you might have exams. So we'll not have a lecture next time. And it's going to be marked as attendance for everyone. Okay? Okay. So with that, it's going to be like, it's pre-recorded and I finished it. It's going to be 25 minutes lecture and recorded. And it's going to be uploaded shortly, okay? All right. Thursday. We don't have meeting on Wednesday. Do you want to come on Wednesday? I'm going to be here. Yeah. No class on this Thursday, the 12th. All right?
That'll be uploaded sometime today.
Today, yeah. The number 16. I just finished recording it. It's like 25 minutes. So with that, let's go over conversational Q&A and story generation. We talked about a lot of problems like last time about what are problems that we can have with generation, that's neural language generation. And we propose kind of fixes for them. And we say you can have, for example, inconsistent persona. You can have multiple personas, 5 sentences persona. You can pick from them, or you can have a large number of personas for which you have this context of I love, I like, I whatnot. And then you can just mimic that persona alongside the output. With that, I think it is worth it to talk about conversational QA and storytelling. And storytelling has its own problems, larger problems, and then how we solve them. So it's going to be conversational QA, and then the architectures, neural storytelling, structure generation, fast generation, and then NLG evaluation. Evaluation is very important. With that, what is the objective of this class, of this lecture? It's going to be to understand CQA and its architectural approaches, analyze challenges in neural story generation or storytelling, like coherence, state tracking, and causality between episodes of the story. and explain the structured and event-driven generation methods, understand non-autoregressive generation for fast NMT and neural machine translation, and then evaluate strengths and limitations of neural language generation or machine generation evaluation metrics. Okay, so how you evaluate. Let's start with the CQA. So what is the CQA? What is the conversational question answering? What is a QA? QA is just like turns of dialogue where you have a question and then an answer. CQA or conventional CQA is exactly that. Okay, so it's a subfield of NLP that enables machines to answer user queries in multi-turn conversation. Multi-turn means that you have a question and answer, question and answer, question and answer, and you have to track those questions for context. Unlike traditional QA, CQA maintains context. So you have to have a good tracking mechanism for the context across those different turns. Make sense? Okay. So what are the key challenges of that? From the definition. So you have context, you need to track this context, and this is a problem. So understanding the previous questions and responses and keeping track of them is going to be one challenge. Another one is what we call ellipsis and coreference resolution. And there's going to be handling incomplete questions. For example, what about the second one? What does it mean? It means that maybe in the conversation at some point, two options were offered, and then you ask about what about, like, say, for example, buying stock to become wealthy? And then what about inheritance, the second one, right? Inheriting the money itself, okay? So what about the second one? Then the AI, the machine, has to understand the context, the broader context, which is from the previous question. Another one is ambiguity and clarifications, which is to deal with vague or underspecified queries. So for example, and this happens very often. So you do not like write formally or write coherently or write like linguistically accurate, like grammatically accurate, and then you expect that to get an answer. And right now, like, when we talk about LLMs, most of those questions that are incoherent oftentimes get answered, and sometimes get answered off on a tangent, and then you have the chance to clarify them. But machines are good at that. We'll see, like, how we deal with this. Examples of CQA are going to be like ChatGPT and Google's Bard or Gemini or whatever you want to call it. And that is what we call open domain CQA. Then there is this knowledge grounded or knowledge based type of CQA, and it's going to be based on some facts. So there's no opinion, facts. Like, you can imagine it as a RAG of sort in LLM's space. And it's going to be Wikipedia-based CQA or QA. And it's going to be called knowledge grounded. The last one is task oriented, and it's going to be customer services, bots, and whatnot. I just got exposed to the customer service business on WhatsApp. So a lot of companies nowadays, instead of like having you to log into a system and deal with it, they have like a WhatsApp number where you can ask them about like most things. Like, for example, you can think of a bank, and the bank has its menu, the voice menu that you can have. They have them on WhatsApp, right? Limiting, but good capability that understand the language and just get you to where you want to get very quickly and very conveniently, because people right now are more comfortable dealing with the phone as a texting mechanism rather than as a speaking mechanism, right? Okay. At an age of 40, I just like started out of need. I started just like being comfortable calling someone and just like asking for reservations or whatnot, right? It used to be my wife's job for the last 20 years. Okay. So again, task oriented is going to be customer service bots. Okay, and those are becoming really popular. Right? So what are the methods and architectures for those conversational Q&A? Well, there are a few of them. There is retrieval base. So you can imagine on the retrieval base that you have some knowledge base, and then you want to retrieve the best response out there for the given question, the given prompt, for the given turn. So retrieve means that like you have a Q and answer, Q, question and answer, question and answer. And then, or like, for each question, you have multiple answers. And based on some additional context, you try to retrieve the best answer for the given turn, for the given question. This is very nice. This is one. And, you can imagine that this comes with an advantage, right? It's very fast. You don't have to do anything. You don't have to deal with any intelligence of sort, right? So you can do it very quickly. Just like, search for like a bunch of answers and get the best out among them based on some similarity metric maybe. The other one is going to be generative. And this is like, so far what we have been talking about in generating text. So it's going to be basically producing responses dynamically using the given context and a model. Okay. And so in the next lecture, which is not going to be in person, we talk about that in the context of what we call conditional language models. A conditional language model is a model that takes the previous utterances of a word, like, for example, a sequence of yt, y1 to yt minus 1, and give you yt, and alongside that yt, it takes also an x. Okay, what is x in the case of, for example, translation? Is going to be the source utterance, right? We call that the contextual vector previously, right? In the case of, say, for example, translation, we said translation. What else? Summarization, for example. In the case of summarization, you have an input and an output, like target output. Make sense? Okay. So, that's good. So we have like those generative ones. And then the final one is going to be the hybrid, which combines both. So it's going to be basically combining retrieval and generation. And this includes RAGs. Okay, RAGs are our best friend right now. So because generation alone will be hallucinating, going off on a tangent, right? With very high confidence, but it's going to be telling you nonsense. On the other hand, retrieval is nice, but it's limited. Because it will generate, it will not generate, it will retrieve from you whatever that is there, right? And so if you have a question that is not specifically written there, or maybe the similarity in the retrieval index is going to be low, then you might get some random answer. So here you combine both to get like the best of both worlds. What are the architectures for doing that? Well, there are a couple of architectures. Let's start with the lower one, which is transformer-based models. Okay, transformer. We learned this transformer. And you can utilize transformers for building a very nice CQA. And so the BERT-based models include QAC, question answering composition, QAC, and then there is CoQA or CQA models. And there is ChatGPT based or GPT based. Actually, ChatGPT is one example of GPT based. So GPT based include dialogue over transformers. This is like what you have like in those GPT based abilities. So this is for transformer based architectures. What about the memory-based systems or memory networks based models? So those are similar in a way. So they store and retrieve conversation history, and that's why like we come like basically where the memory comes from, because you memorize this history and retrieve this history. And the good example for that is DRQA added to that network of memory or memory networks. Okay, so this is great. These are architectures, and there are sets for training and evaluation. If you are working on in this space, there are a bunch of those. So there's CoQA, which is a conversational QA, which provides you with context-dependent dialogues with free form answers. There is a QAC, or question answering in context or with context, which is a QA over the Wikipedia context with multi-turn dialogue. And then finally, there is DOCA, which is domain-specific CQA, which is question answering for domains, like, for example, cooking, travel, name it, okay? Any questions? Are we good? Okay. All right, so let's talk about some data sets and some QA kind of systems or models. So the first one is going to be Stanford NLP's new data set for CQA. So the set overview. So it's developed by Stanford, as the name indicates, and it is for CQA. Focuses on answering questions about a given text in multi-turn dialogue, and answers are basically established abstractively, not directly copied from the passage. So this is like in a way similar to the abstractive summarization that we talked about, where you generate the output based on some training formula. And the key characteristic of this is actually a hybrid. So it reads comprehension. Extracting the reasoning over the text, and then dialogue understanding, so maintain conversation history. And this is context aware in the sense that the questions depend on the previous turns, and it has abstractiveness, so answers require synthesis, not verbatim generation, even if it is not doing retrieval. So the text is going to be given, like, for example, Marie Curie. Curie was a physicist and a chemist who discovered radioactivity. Then the question is, what did she discover? She here is going to be coreference resolution, right? So she discovered radioactivity. That's based on the text. And how did that impact science? Well, it led to advancements in medical imaging and nuclear physics. Now, if you just like read it casually, you don't understand the complexity in this as a language, but how did the discovery back science that is factual, actual Q&A, like Wikipedia based. And, she, in this case, she refers to Marie Curie, and then that's it. So Leuciva is going to be basically addressing all of the problems. And so here's another example. For instance, we can start with something like Jessica, like this is the context, like a large context, like Jessica went to sit in her rocking chair. Today was her birthday, and she was turning 80. Well, happy birthday, Jessica. I can't imagine a Jessica who's 80 years old. Can you imagine that? Okay, not Jessica. Right, not a Jessica, right? Do you know any Jessica who's like 80? Oh, really? Oh, well, like somebody was born at some point in time and was Jessica. Oh, they are our age. Yeah. Yeah, I mean, we're not grandfathers yet. Yeah. Okay, so Jessica, who's turning 80, her granddaughter, not a grandmother, thankfully, Annie, was coming over in the afternoon, and Jessica was very excited to see her daughter Melanie and Melanie's husband Josh were coming as well. Jessica had. Okay. Then the question is going to be based on that context. You have to keep track of that context based on transformers, maybe, for example, memories. So who had a birthday? The answer. Jessica went to. So then, like, this is a Q and A, and then the response rationale. So Jessica went to sit in her rocking chair. Today was her birthday, and she was turning 80. So this is extraction from that. This is going to be basically the rationale supporting this answer. And then how old would she be? And then 80, she was turning 80 from the context. And did she plan to have any visitors? Yes, her daughter Annie was coming over. How many? 3. How many? Like, it's like short. It's a short question that lacks context, but you have to like understand the major context to be able to answer this question. And so 3, her daughter, blah, blah, blah. This is the context. Who? It's like email acts like more context, right? Annie, Melanie, and Josh, and her granddaughter, blah, blah, blah. That is the context. Make sense? And so those are the terms, okay? And this is like the way in the Stanford NLP and UTLS paper. All right, any questions? We're done with CQA. This is one task. Now you know what is CQA, right? CQA. Fixtures, data sets, what does try to address, what are the challenges, all of that. All right, let's go over storytelling. Storytelling is the best, most convenient kind of way to communicate ideas, by the way. And so we are scientists, we are like experts at storytelling. I mean, not really experts, we try, right? That's why it's, sometimes we do not like do well and we get rejected, maybe. But with storytelling, I was not talking about anything. I'm sorry. He just got rejected. No. Just like in general. I got rejected three times last week. Okay, so storytelling is like a great thing that was like invented long ago, before scientific papers were a thing, right? And so, what is storytelling in NLP? So the ability for AI to generate coherent, engaging. How many of you read stories like novels and whatnot? Raise your hand very high. Used a lot? Yeah. Yeah, it's a very nice thing. I mean, like I still like read some novels from now and then, but they are my kids' novels, so they buy like those novels, and then like I find them all everywhere, and then I read them. So they are engaging indeed and structured. They have to be structured like in narrative. So you have like episodes that follow from one another and just like build events based on those, scenes based on those. And so it requires understanding more maybe a parallel or serial plot of sorts, characters development, and stylistic consistency. Applications of that would include automated content generation, like fiction, news, summaries. I hate the summaries that are generated by AI nowadays. Every website is the same, right? It's the same. It's just become banal and frustrating, right? Yeah, and now like where to find like things like it used to be very exciting that like if you read some piece of the news, you have to scroll down. Now like, oh, I know where it is. Just like scroll to the line number 20, and then you find like whatever you're looking for, like who did what, right? So anyway, it's not engaging anymore. But so automated content generation, like fiction and news and summaries, they could be like for interactive storytelling, like AI-driven game narratives. I think that your advisor does some of that, right? Like developing characters in virtual environment and then building those kind of stories. It's very nice. So it could be an interactive storytelling, like AI-driven game narratives, or even actually in games. In games, my kids told me that in games, some characters are AIs, and they interact with them based on their own behavior. Okay, so you have kind of have like a player that is AI, And that's not to say like, they are players. They are like players in the game to challenge the player, to give the illusion of like there are so many people out there doing this. Okay, it's going to be more engaging. And there is assistive writing tools for authors. Many of you use that, right? Yeah. Okay. So you can use it like for publishing. You can use it for like telling a story, right? For authors, you can like say like, oh, what if I just like modify this character in this way? Would that be like appealing to the readers or not appealing to the readers? Make sense? Okay. So key challenges of that. These are the challenges we'll go over very quickly. They include like coherence and structure, so ensuring that there is a logical story progression and you are at the story level, you are not like hallucinating. Character consistency, so maintaining attributes across the narratives. You cannot like have a very nice, kind, whatever character, and then suddenly he's like cursing and whatnot, right? So it's not expected. Creative versus factuality. Or creativity versus factuality. So you need to balance the imaginative storytelling with the realism, depending on the context. And then finally, user interactivity. So adapting dynamically to prompts or to reader input, depending on the context. Okay, so what are some of the prompting strategies for storytelling? Well, there are a few. There are control the prompts. And so those controlled prompts will provide structure for guided story generation. The example that we have here is write a mystery story set in 1920s Paris. I don't like Paris, but Paris, featuring a detective solving an art heist. It's interesting. This is like what most of the noir kind of stories look like, right? Or novellas look like. And so this is what we call controlled prompt. So you control everything in the narration. There is the open-ended prompt. And so this is going to be encouraging creativity, as anything open-ended would do, without strict constraints. So the constraints that was like the time, the location, the featuring of what, right? So you have constraints here. You don't have any constraints, okay? And so like the example that we have here, a scientist discovers a hidden dimension in their laboratory. Like, it's just giving them some context and then take it from there. Make sense? That is the most amount of freedom that can give anyone with that. Then there's character-driven prompts, which focus on the chronologist of the traits or the goals or whatnot, but it's something central to the character, okay? And this is like an example that we have here. Describe an astronaut's emotions as they wake up alone on Mars, right? It's good. Anybody went to Mars? Like a person? I've not been following the news. I thought like Elon Musk once sent somebody, right? No, nobody did that, right? But yeah. I read some conspiracy theory recently, which is that Elon Musk is producing those trucks that are solar in a way, so like he sent them to Mars to do the navigation and whatnot, right? Did you read that? Yeah. There is one theory. I think he created it. Go ahead. Yeah. I see. Oh, I see. Right, and they are visually ugly, right? Like visually very ugly, and they are bad utilization. If you ever like drove a truck, then you know that they are like bad utilization of space, right? A truck should carry a trucky thing, right?
Parking spots are getting smaller and smaller.
Right. Oh, you have to go live in South Korea to know what smaller means, right? So yeah, actually driving up in a mall in South Korea. How many drove there? Nobody? Okay. So you drove there? So going up in a mall, like you can see that a lot of people have done accidents because when you look at the side of the ramp, right? Up and down, and it's like scratch, right? But it's very like you have to be like, if you can't drive in Seoul, you can drive anywhere. Maybe not in Cairo, but like anywhere, more or less, right? Parking spot, yeah, expensive.
Extremely small.
Yeah.
You're like, you're lucky to get one that's like close to like say like Whole Foods or Target or whatever.
Yeah. They have ABC. They have ABC. They don't have like what are those? They have ABC shop. Are you from there? Yeah. I see. Yeah. Before I meet you guys, I used to go there every year. I mean, like before I come to UCF, because then UCF became like in Florida, and it's like, what is the point of going to Hawaii when you are in Florida, right?
Yeah.
You can go to like you can go south, like South Beach, or maybe like the Keys or whatnot. It's similar.
You're coming from Orlando, Los Angeles.
5 hours and 4 hours.
So
Yeah.
it's like additional 5
9
hours.
hours. 9 hours.
Why don't you just go into the
All right.
multiple
Yeah,
lands?
yeah. I've never been there, so yeah, I've never been to the Caribbean. I always travel away, like to Europe, to Paris, which I hate. Okay, so multi-tier interactive prompts. These are like lecture-driven, so multi-tier prompts, like AI and users co-develop the narrative, right? So example, user by block twist, and then the AI continues the story dynamically based on that prompt twist. Enhanced storytelling with NLP models, so the pre-trained models like GPT, BART 3.5 for text generation, they can be improved. Fine tuning, you can train models on a specific genres. Genres? Is that genre? Is it genres or yeah? Genre, right? Plural is genre, right? Right, genre. What is the singular? Genre, okay. Okay, so genres or storytelling data sets, and then finally the memory augmented AI, which is training the context across multiple turns, story development. Like, they call CQA, but this time is like going to be story. Okay, so storytelling applications, what applications we have? There are a lot of them. There's automatic content generation, like news articles, which is right now used in most places because it's very quick, extremely quick. Generating news, AI generated journalism, like GPT-powered news summaries. Again, they are just like not as engaging. Creative writing, so assisting novelists, poets, and script writers. You have like Sudowrite, for instance, is an example of creative writing. Or some of our research papers nowadays are totally written by AI, right? Research papers. You have to deal with that. Marketing and branding is another thing. So AI-driven ad copy and storytelling, like Jasper AI, can be a good example. Right now, we have a lot of things like for students, right? Like you can create with what is that? Banana, something banana. It's like from Nano Banana. How many have used it? Nano Banana is just like a slide generation, well, not say image generation using Gemini, right? It's a Gemini thing. Well, here's the thing, because it just give you images, so you have to convert those images into actual slides. Yeah. No, this is an old one, old news. Yeah. But the problem with the AI is that it makes everybody looks the same. Like I think the good unique thing about humans is that they are different. Like in here, like how many of you use the same shirt? None. And that is like a very good thing. So we have to like appreciate that, right? Megan, what's going on there? Laugh with us or make us laugh. Nano Banana. Okay. Oh, perfect husbands. Okay. That does not exist. Okay. Yeah.
Oh, you're right. Let me try your dad. He's on your phone. So I tried my dad, and I was like, yes.
I think yeah. I asked it. My wife is Asian. My wife is Asian, so I asked her, "What is the perfect wife for me?" And it's an Asian woman. Any Asian woman would do, right? Probably because I asked like Gemini or ChatGPT about a lot of questions to do with South Korea, right? A lot of questions about currency, about investment, about what should I do if I visit like right now and whatnot. So and that is not because I do not know what to do, but just like out of curiosity, what this collective knowledge has to do with. And give me like the image of, did I show it to you? Yeah. So an image of a person who's Asian, and like this is the perfect person for you, like the perfect like wife for you. For a man though, if a woman asks like what is the perfect husband, and the man is a lot more complex of an issue than like being a woman, right? Because then we'll talk about that later. Okay, this is recorded. So anyway, so there is the automated content generation. There's interactive storytelling. We finished that, like the marketing and branding. Interactive storytelling in games. You have AI dungeons, which is procedurally generated text based on some adventure games. Chat-based RPGs. Role play games. So AI-powered dungeon masters that create dynamic narratives. Finally, there's the branching narratives, where games that adapt based on player choices, like AI-driven game and non-player characters or NPCs. And then finally, there is the personalized storytelling, where you can do like children's storybooks, AI-generated bedtime stories. Right now, like most AI assistants do that. Assistive writing tools, AI co-write suggesting ideas and plot twists. And then finally, therapeutic storytelling, which is AI-generated narratives for mental health applications. Okay, so these are the applications. They are great applications. But then there is the even fancier application, which is using the idea of captioning, and that is storytelling from images. So you can basically have a visual storytelling, which is the process of generating narratives based on some image. And so that's going to kind of combine both image understanding or computer visions and natural language processing together, right? And so there's going to be used to interpret scenes and generate coherent descriptions. By the way, a question off on a tangent. We know what MLMs are, right? What are they? Multimodal language models, right? So multimodal. So in multimodal language models, how do we do the representation of images and text? Embedding, but like, do we have like the same embedding for the image and the text? One idea. What do you think? What do you think, Ken? Are they the same? The embeddings for image and you don't think so? Separate? But then how do you relate them to one another? Alignment, yeah. You have both choices, by the way. Like there's no right answer here. You can have them the same, but then you'll have to deal with capacity. Then you'll have to expand the capacity for something that is not really required the expanded capacity, like the text. Text is just like does not require the capacity as compared to the images. So you'll have to have like high cost for the embeddings. And you can have them different. You can have like, the image is different embedding in the same space, but different embedding than the text. And then you have to do some alignments for them. Like align the embedding of the image to the given text so that you can have relatedness of them. Make sense? Come again? I don't know. Yeah. Frog is the masks thing, right? Yeah. I mean, like if it uses anything, it's not really using it very well, right? Because like this is a racist thing. And by the way, to make it behave, then people discovered there is a prompt classifier ahead of the LLM that asks, would Elon Musk approve of this? You saw that? Everything is good? There? All good? All good?
Yeah. Coming for work.
Oh, okay. Give him your name. Give him your name by email.
Okay. Yeah.
Okay. Yeah, no worries. So it does that. Like, would Elon Musk approve this, or would it like basically embarrass Elon Musk if the output was generated? And that's because a lot of things have happened in that space. Okay, so it combines like NLP and computer visions to interpret scenes and generate coherent descriptions. Applications of that would include assistive technology for visually impaired users, automated photo captioning, and creative writing with a prompt from images. Technologies using that is going to be image captioning models, include multimodal models, and then the sets for that would include MS Coco, visual storytelling, the sets like this, among many others. Storytelling from images is another application. So image understanding is computer vision. So you have object detection, you have to detect the object and then build your story based on those objects and their interactions through some scenes. So you have like object detection. And so for that, we have different algorithms to do it. YOLO, What does YOLO mean? Huh? You only live once, but it's not like you only live once. YOLO? You only look once. You only look once. You only live once. YOLO, right? So this is like the same, different YOLO, not the same YOLO. So there are also like the faster RCMMs, which are used for object detection. There is scene recognition, like Resonate and Clip. And then this is the first one, just like image understanding. The second aspect is going to be caption generation based on this scene or image. And that would include a combination of NLP and deep learning. And this is going to include something like encoder-decoder architectures, like CNN for encoder, which is like very cheap for an image, and then LSTM for the decoder, because then you have to generate language. LSTM is good for sequences generation. Transformer-based models like VIT-GPT-2 is a good example also of the caption generation, which includes both the elements of the transformer of the encoder-decoder in transformer. Narrative expansion. So the basic caption would be like a child playing with a dog in the park, and then once you have that context, then you can expand the story by adding additional context. So, for example, on a bright afternoon, Sarah laughed as her golden retriever Max chased a butterfly through the green fields. This is typical, like KG or toddlers kind of story, right? And so, and then a child playing with a dog in the park is kind of materialized into this very expanded story. Any questions? Okay. So overcoming the lack of parallel data. What is a parallel data? Parallel data. What is parallel data? Parallel data. Yep. Okay. This is one interpretation. What is parallel data? Come again, come again. Yeah. Yes, we have a source and a target, right? So we have like, so for example, we have a summary, and for that summary, we have another extraction of that summary. For example, like, we have vulnerability description. From the vulnerability description, we have a description of the version of the software affected, the vulnerability type, blah, 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 blah. So multiple descriptions, multiple utterances that correspond to the same context, okay? And so that is a challenge. So the challenge, there's no parallel data for storytelling transfer, or for story transfer, or style transfer, or even translation. So many LLM tasks require aligned parallel text pairs. That is like, to have the original, like, context, and then, like, a line from it, a small line from it, a small episode from it, okay? Like a branching for the episode. We'll see that in the next figure. And so the alternative is to leverage, alternative to that kind of parallel, is to leverage a common sentence encoding space to bridge different text domains. This is one option, right? We said you can have like multiple encodings. Here you do like, one embedding, one encoding. So a solution for that is going to be the skip thought vectors, which is like one encoding for sentence embeddings. And so it's inspired by word embeddings like Word2Vec or GloVe, but at the sentence level. And so skip thought vectors would learn representation by predicting surrounding sentences and the corpus, and they enable unsupervised learning of semantic meaning across the different text styles. So for instance, here we have, I could see the cat on the steps. And then you have like, for example, a word here, like, steps, and then steps will give you a generation, use it for generating those multiple parallels. So use generation here through some skip vectors. And so you have like, I got back home. That is the following. Or you can have, this was strange, for instance. And then if you learn, if you watch the next lecture, you will know like how we do the selection. How we do the selection, which one is the right one for selection, right? So this is corresponding to what we call a beam search. Beam search. So you use this one as the context, and then you generate based on some beam size. Like you can have like, even four beam size 4. And then you select multiple candidates, and then you check those candidates, the parallels, you check them for which one is more appropriate. Make sense? Okay. This is beam search. By the way, I have a question. So this is PIM, right? This is PIM. It's called decoding, PIM decoding. What about this? You'll have it next lecture, but what is it? We explained it before, that's why I'm asking. Like, so when you have like a linear prediction, not like a branch prediction, what we call it? Huh? 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 No. 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 Huh? No. Decoding, not like a autoregressive generation, right? Decoding. Greedy, right? Greedy, because you are like selecting only one item at any point in time. Greedy. If you are generating multiple, then you're not greedy, right? Huh? Meaning? So greedy based on like, because this is going to be the generation is going to be a probability. So you have from here to here, you have a probability distribution, and you pick only one word, the top word, right? The most likely word. The most likely word because you're having the max, like argmax for the probability. It's going to be greedy, like you are selfish at this point. You can be like smarter by saying like, you know, I'm going to select two items and then continue with them and see like which one makes more sense, which one is more coherent, or which one is more aligned with the context in the storytelling, right? And that is called PIM search. Or you can use actually sampling. You can have like 5 options sampled from the top probability and then use them. Or you can use top K, top P, like top P, or you can use a random sampling. A lot of options for that. Okay, anyway, so that is actually something that we will learn about in the next lecture. So this is what we how we overcome the lack of parallel data, which is very important in storytelling. Here's an image that I took about a year ago, last year. I used to be into walking. Cristo Manolo Trail, do you know that place? Anybody knows that? Anybody live in Oviedo? Oviedo? Yeah. Oviedo is one of the unique cities. It's an old city, by the way, like old in the sense of like this country, like 120 years old, or no, now it's older. 1925 Oviedo? Really? No way. Because Oviedo High School is the 100, huh? Incorporated, not founded. Yeah. It cannot be. Yeah. 1700. Yeah. No, 1700, I think. Like one very old. Incorporated as city. Yeah. It was something here. Yeah. So it's not like it was not inhabited. It wasn't inhabited longer than that. Yeah. So in any case, Oviedo High School is like just like turned 100 years old, like a few years ago. Yeah, while my kids were attending it. Yeah. I see actually that it was like it's like 1925. I see it when I used to run. Yeah. So anyway, so this is the image, and then just like this is ChatGPT, by the way. And so a story as a son, Deb, blah 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 blah. This is like, you know, what it tells about this story. Actually, this was in the morning, not in the evening. It's like wrong. So peaceful, like, you know, this is the caption: a peaceful that way, embraced by lush greens, greenery, leading into the golden glow of the setting sun. Right, and then, you know, here's like more description, like the image depicts a day that way, blah 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 blah, and whatnot. Okay. One of the great things about Oviedo is that it has a lot of greenery. So the city is a little bit conservative about allowing construction. Yeah, and that is like thanks to our mayor. She's like a very well-established person. Got her degree, I think, from Yale. Her law degree from Yale, and decided to come here and just like be a mayor for $25,000 a year, something like that. Yeah, very cheap. So anyway, she's like, but she's very activist type of person. She's like, you know, her family, a few generations are from Oviedo. Yeah, Megan Sladek. Yeah. So anyway, so this is a paper that addresses the problem. So it's Fanon et al. Convolutional sequence models, and so it is a complex sequence architectures designed for efficient text generation. It has a convolutional-based system that makes it very fast. Incorporates gated, multi-headed, multi-scale self-attention. What do we mean by gated? Gated. like the gates that we learned, like GRU, LSTM. What does multi-headed means? Multi-headed? Multi-headed? Anyone? Or a bonus? Okay, multi-headed. No, do not improvise. If you not know it, just do not tell me. Okay, just because of bonus, you will say something. Okay, multi-headed in the context of CNNs. So you have like, multiple CNNs working at multiple filters. It's like each of them is considered a head. Okay. What about multi-scale? Multi-scale, same thing, just like the size of the CNN, right? It's like you can have like a scale that is narrow, like 1, 1, scale that is large, like XX, X by X, and so forth. Self-attention, we know what is attention, but self-attention is like it looks at the sequence itself. To enhance the performance. Performance here is not really performance in the sense that you are reducing computations, but improving the outputs. Okay, key components, self-attention for long-range context, gated attention mechanism, and then multi-scale attention, fine-grained versus coarse-grained, and whatnot. You guys are really bad at cheating because everything I ask is there, and it's good. I mean, like, you don't want to cheat, right? But like, this is a bad thing in the grand scheme of things because I give you the questions for the exam. Everyone should get 100, right? Right? And still I got like 100, in the best case, 180. All right. So model fusion is another aspect in storytelling. So two-stage sequence model fusion in this particular work. So the first sequence model, you can have pre-trained phase. You learn generated general language models and capture some broad syntactic and semantic patterns. In the second phase, you have access to the hidden states of the first model, and you can condition those on some prompts. So conditioning those on the prompt will give you more relevant answer or relevant extension to the story. Key benefits: it improves fluency, enhances coherence, and more efficient than RNN-based models because you use CNN as your encoder. Another one is Phan's work in 2018. So it has been collected from Reddit's writing prompts, some Reddit, and designed to facilitate story generation, research, dataset structure. Each story is a parallel dataset, so each story is paired with the brief writing prompt, and each training or enables training models to generate coherent narratives and captures a wide variety of creative writing styles, and this is an example of it. Another example of it is here, so this is like really plausible. With that, any questions? With that, let's go. Yes, please. What is the question?
Reading about it.
Okay. So what are attention mechanisms? Attention mechanisms. Anybody knows what is an attention mechanism? What is it? But they are not from the same sentence. Attention is just like another architecture that is trained and then can be added, the attention memory of sort that can be added to the generation process, right? So it has like a very simple form. It's like defined by some K, V, and S, right? 3 parameters. And each of those parameters is a matrix, is a learned matrix, right? It's a learned matrix in the sense that you have to train on a large amount of data in similar space to be able to use it to guide the generation with memory. Okay, that is attention. Good? Okay. Self-attention, on the other hand, is something similar to the gating that we have in LSTM, simpler. Okay? So it is trained on something, but conditioned on parts of the sequence that you have. That is self-attention. Attends to the sequence that you have, more or less. Make sense? Okay. There's a difference. There's only difference. So in both cases, you have like matrices that are trained, whatnot. The condition in one is going to be on the sequence itself, and then in the other one is going to be like free form attention versus like self-attention. Okay. All right, so let's go over challenges of story generation. It's going to be the end of it. So some of the challenges is going to be fluency versus coherence and general AI. So neural language models can generate fluent text. However, they lack coherence. So you can have meandering narratives with no clear direction and nonsensical plots lacking logical progression. What is missing here? So stories are not just word sequences, but they carry event structure and causality. They have character development. They have state of the world, like surrounding the world. You have narrative structure, and you have good story principles, like avoiding dropped story elements or inconsistent details. You cannot just like suddenly kill a character in the story without. Come again? Does it do? I watched it. Like yeah. Actually, I watched Breaking Bad as just a result of peer pressure. every white friend of mine has kept talking about it. That I just like finally I said like, oh, I'm gonna watch it in 2 weeks. And I did, right? Like all evenings, weekends, whatnot. I like it though. Yes, I did. El Camino is a movie. Oh, forget about it. I don't want to go there. I watched. I don't want to go there. So, Better Me Saul. I watched Better Me Saul after that. Better Me Saul and Breaking Bad. What I'm saying is that I don't have the patience to like watch that one. It was just like a result of peer pressure. I have this friend, Will Noland, and he's like all the time, like throwing references to that one, references, and so I had to watch it. I don't have patience for that. But you cannot kill. I'll try to finish like this lecture. So you cannot kill a character and just like hope everything will be fine. Maybe in what is that? Game of Thrones, you can do that. Okay. Okay. So how you can deal with those problems? Some of those problems like consistency of events, because this is something that is very important in storytelling. So we have a way to kind of make a consistent storyline with events, with another event. So this is what we call event-to-event story generation. And so the way that you do it is that you just like generate events as embeddings, and then you just like generate the next event based on the current event. So what is event-to-event story generation? It's a structured approach to story generation where events drive the narration or the narratives rather than predicting the word, like next word at a time. So you have an event being predicted, and then it just like it drives the narration, and then the next event, and then the narration, and so forth. You focus on generating a sequence of logically connected events to improve the coherence. And this is the structure of it. So you have event representation. So events are structured as subject, action, object, and context tuples. And examples like the hero defeats the villain in a final battle. This is the event. And you have then event transition modeling. So from event to event. So you have predicting what happens next based on the causal relationships. And then you ensure some logical progression instead of the random word sequences. I think that solves the problem, right? So you have event. The event is going to be itself somehow represented, and then you have transition between event to event, right? And then you then add character and real world tracking to kind of make sure that the characters in the event are consistent. So you maintain the consistency of the character motivation, settings, and story elements. And then you can have narrative control. So the plot structure, like rising actions, climax, and resolution, are going to be incorporated into that. So it improves long-term coherence in storytelling this way with event to event, enables causal reasoning, and then it is more interpretable. Okay. The next one is structured story generation. So what is structure here? It's going to be a controlled approach to AI-generated storytelling. The narrative is going to follow predefined structure rather than a free-form text generation. We talked about that in definitions. It ensures coherence, a logical flow, and character consistency, prevents incoherent and aimless storytelling, enables causal reasoning and long-term plot consistency, and allows user control over narrative. The key components, you have event-based planning, where the stories are modeled as sequences of events. And the example is going to be basically a hero receives a prophecy, and then it trains for the battle, and then faces devil, and then triumph. Character development and consistency is another feature of this, component of this. AI tracks the personality, goals, and relationships over time, and it prevents inconsistencies like character forgetting and past events. And by the way, none of the current LLMs has that kind of feature, right? like a tracking, the tracking. You have to remind it, like, you know, if you are paying attention, then you have to remind your LLM that, like, oh no, this is not right. Get back to my original prompt, right? Get back to my, because like keeps branching. And so if you not follow, if not know like what you are doing, you will get into like a hallucination world that is like plausible, but does not really capture the context. Yeah, and if you know what you are doing, you'll like figure that out. It's only after a few turns, right? You know, I do a lot of thinking with ChatGPT, and I know what I'm doing with my thinking, and so oftentimes just go on a tangent. And I know what I'm like what I want, and I know what I've given it, like the bases, but it just like keeps shifting from the bases. So be careful. Okay, so this is one. You have another component like world state management. You have narrative structure enforcement, and you have hybrid model approaches that combine neural with the symbolic AI like event, graphs, causal modeling, etc. This example is going to be event-driven models plus block graphs. Those are like, you know, a nice example. Structured storytelling, this is like what it looked like. So you have a story prompt given, and then you have like a structured action plan with semantic role labeling. And then that would lead to the anonymized story. And then you fill into that anonymized story the given is full story. This is from the same paper. It's tracking in neural language understanding and in neural language generation is another aspect. So tracking events, entities, and states in NLP is very important event task, where you have event progression, entity tracking, and state changes. The key research, she just moved to Stanford University. So this person, Yijin Choi, she moved from University of Washington to Stanford. She had like most of the major contributions in that, event progression and tracking and state changes, for which she got the MacArthur Fellowship, the Genius Fellowship. Their work focuses on inferring implicit event sequences and reasoning over causal effects. Okay, so how this works? So applying basically state tracking added some challenges like generating open domain stories while tracking the state, like in the case of ChatGPT that I highlighted earlier. NLG must not only like understand the state changes, but also predict the generation coherently. A more manageable approach would be what we call recipe generation. So instead of open-ended storytelling, you give it some directions. So the ingredients will be like raw, chopped, cooked, or the tool usage like mixing, baking. Mixing would imply baking. And then temporal ordering, like do not, for example, bake before mixing. Make sense? Okay, so there's some rules that you can add. Why this works? Well, because recipe provides some clear directions of event sequences and state changes. Also, it enforces some domain constraints. For example, it helps you control and evaluate coherence in this space, and easier to apply to state-aware neural architectures. Any questions? Yeah. Tracking a character. So you have like, say for example, the character eventually is going to be in a given state, and then is going to move to another state, another state, another state. You cannot say like, for example, David cooked right now. This is like the state. Cooked or like baked the bread. But then he mixed the flour. Make sense? The actions themselves have to be tracked, like the character itself and its actions have to be tracked to be logical. Make sense? And so you can do that like with generation, like you can build a model that understand the real world phenomena of ordering of events. Very difficult. Or you can give it a set of rules, what we call a recipe, that those certain events cannot happen in different order. You have to like maintain the orders. So in generation, you just like hold back before you spill out the generation until you make sure that the recipe is met. Make sense? And the recipe, the reason why we call it recipe, I mean, like this is the example, silly example, I know, baking and mixing, but that applies to like all complex events, right? You cannot like, for example, kill a character and then like talk to them, right? Make sense? Kill a character, like, kill an enemy in the story and then talk to them, right? Make sense? Okay, so another episode, you can talk to them, right? Maybe like in your head bubble, right? Something like that. But that is what I mean by tracking. You track the events and character, yeah. Come again?
How much does it track?
How is what? Oh, for the entire story. For the entire story. You have to track the character for the entire story. Each character. You can even like, track them for the internal state, like for their emotions, for example. You cannot like be like an angry character, like angry, or like, always angry. Like, if the trait for you is angry, unexpected from you to be nice, like me. I'm not sure like I'm the nice or the angry, but like I'm saying, okay, makes sense? Okay, all right. So that is that. Now let's talk about something that is entirely different, just like out of nowhere, which is non-autoregressive generation for NMT, right? So what is autoregressive generation? Autoregressive. Yeah. Yeah, you just like generate the next based on the previous. Okay, non-autoregressive, something different. Okay, so in translation, in neural translation, neural machine translation, you have the context vector, and then you have like a starting. Megan, with us, yeah, attention. So you have like the contextual embedding from the source language. It's going to be the last state in the source language, and then you have a starting for the target, and then you generate, right? You generate based on the previous one. Like the previous context will mandate what is the next word, right? So this is something different. So how does it work? So it's traditionally autoregressive NMT, which is transformer based, generates the words sequentially, where each word will depend on the previous bunch of words or outputs. Non-autoregressive generates entire sequence in parallel. Amazing, right? All of them in parallel. It's going to be like real time, no latency, right? It's very nice, very fancy. Advantage for that is going to be faster. It's going to eliminate exposure bias, and it's better suited for real-time applications. How this ugly thing works. So it has something called masked language models, like BERT style decoding. And so what you do is that you predict all tokens at once, given the context, then refine the missing or low confidence word. This is where the masked language model come from. So you have like a generation, and then you mask some of those because they are low confidence, and then try to fill them based on maybe on the previous ones. Okay. For that, we have what we call the Levenshtein transformer. There is also latent variable models. This is another approach which introduces latent representation of sentences to guide the parallel token generation. And then the example of that is going to be a flow-based NATS models, and which use probabilistic modeling to generate smooth translations all at the same time. And then there is a third one, which is iterative refinement table models like CTC-based NATS. And so there's going to be generate the initial draft and then refine through some multiple decoding passes. Okay. Again, what is the decoding here in this sense? It's just like because well, when we had it before with the encoder decoder, and the decoder and the decoding, for each of the generations, you have a decoding, right? You have like a decoding step. You have a probability, and the probability still is going to be decoded to the highest likely, maybe like with a greedy, or maybe to the top K, well, you predict random and whatnot. So you generate initial draft, and then you refine through some decoding passes. The example is what we call conditional masked language models. Conditional is something that you learn about next lecture in more details. And the challenges and trade-offs, so fluency gap. So you convert it to regressive models. It is some fluency gap because you are generating everything at the same time. Difficulty in handling long-range dependencies because, again, you are generating everything at the same time, so you do not have awareness of the dependency, and requires additional refinement steps. This is the diagram of it, how it works, but this is not really something that I'm going to go over. But you can imagine that all the inputs of the in the given source language are going to be handled with this multi-head self-attention, multi-head positional attention, multi-head inter-attention with an MLB component, and then softmax to get you the destination language, target language. The last part, I promise. Okay, this is very important, which is evaluation. We talked about that before, right? So we said that you can evaluate based on overlap. And so overlap based, D is used like a typo, very quick. So we have Blue, we have Rogue, we have Meteor, we have F1 scores. We know them, right? We do not need to define them. What are the limitations of those? Well, in summarization, for example, more open-ended than MT, multiple valid summaries exist. And so this is the problem. You cannot really just think of an overlap. It's going to address this problem. Rogue favors extractive over abstractive summaries. And this is really bad because bias models towards copying, more copying to basically to maintain this overlap. In machine translation or MT, struggles with the paraphrasing and synonyms because, good and amazing, they are like in the same kind of world meaning, semantics, but then they will not have greater overlap, right? It penalizes valid translation that use different wording, right? Okay, so why these metrics fail for dialogue and story generation? This is our example. So dialogue generation is going to be responses that can vary widely, like references or generated aspects. Fail to capture the conversational appropriateness. Story generation has multiple valid kind of responses or narration exits phases. Lack evaluation for plot coherence also is another issue. Alternative for word overlap in this case is going to be BERT score, which uses contextual embeddings for semantic similarity. There is mover score, which captures the word shifts in meanings using some form of embeddings and similarity between those embeddings. And there is dialogue-specific metrics like engagement, relevance, and coherence-based human ratings. This is going to be human evaluation. And story evaluation metrics like narrative coherence scoring using structured event modeling. Some of the automatic metrics, again, traditional word overlap, like those, fail to capture the important aspects. And oftentimes do not really look at some features like fluency, style diversity, and relevance. And those are all human metrics, right? So the fluency, style, diversity, and relevance can be evaluated by the human. So the method for that is going to be either computational under well-trained models. It's going to be guided by a human with their reinforcement learning. Correct style can ensure outputs follows the desired tone, whatnot. This is by a human, or can be done also by RLs. Again, RLs is going to be like matching the human preference. Diversity, evaluate richness of vocabulary and original text, and can be captured with some rare world usage or whatnot. Has to be annotated again by a human. Relevance to input can be assessed by semantic similarity scores. Basic structural metrics can be done with length constraints and repetition detection, which is very easy. Task-specific metrics, you can design specific for tasks, like, for example, in summarization, you can think of compression rate, which is a great one. Human evaluation is our golden standard. So I mentioned that a little bit with other metrics as like an aiding mechanism. It's considered the gold standard for evaluation, captures aspect like automatic metrics, and they can struggle with it. Challenges with the human evaluation, it's very slow because the human has to deal with that. And we do not have many humans that can deal with that as compared to computers where they can run very quickly. Also, humans are very subjective, right? You have like a world of view that influences how you approach things, right? So, and there are a lot of studies about this showing it. There's also cognitive limitations, like people have fatigue. Like right now, I talk only for 1 hour, and then like I feel like exhausted. I need to sit on a chair, but then thankfully somebody took the table that was here that I would sit on. I'm messing with you. So cognitive limitations also include loss of concentration over long evaluations or misinterpretation of prompts or whatnot. We humans are very great at misinterpretation. Alternatives, hybrid approach is good, or crowdsourcing strategy. So you do not have like a single human doing the evaluation, but multiple humans to scale. But then having multiple humans will like make things worse sometimes. Because if you have one subjective individual, you can train them, but you can try to understand their bias and then try to mitigate it. But you have like 1,000 biases, right? Good luck with that. Okay. This is like a summary of what we have had. This is just like summary for summary. And then these are the key takeaways. So CQA requires context tracking, coreference resolution, and multi-turn reasoning. Fluent LMs does not mean coherent ones. And structural generation improves the long-term consistency of free-form decoding. And non-autoregressive models trade off fluency for like speed. And overlap metrics are limited. Semantic and human evaluation is very important. With that, I'm done. Do you have any questions? Yes. Megan, I don't think they are allowed to ask questions because you keep interrupting me by like talking to your colleague here and laughing. But go ahead. Really? Did you check it out? What was the problem? Really?
Yeah.
When was it supposed to be posted? After the break, yeah. Yeah, that's fine. After the break. I want to work. When is after the break? I don't think that I require them to work during the break.
No.
Yeah, I don't require to be working. Make sure. Assignment number 4, not 5. No, it's not a bonus. Yeah. It's like that's what it's called, like star 1.
Assignment 4 was March 9th, so that's passed.
Yeah. Yeah, thankfully we have a bonus. No, I'm messing with you. No, so we will find a way to do that. Yeah, thanks for reminding us for that. Any questions online? Give me one second. All right, thank you everyone. I will see you next week or next